Alright, Section 1, oxyacetylene apparatus. Fundamentals, gas cutting, and welding. This is not my course. Section 1, oxyacetylene apparatus. Before discussing how the system works, it is important to know that the name of the component makes oxy-fuel apparatus. Oxy-fuel apparatus consists of two cylinders, one oxygen, one oxyacetylene, equipped with the two regulators, pressure gauges, and the two lengths of hose, a blowtorch, and the regulators are attached to the cylinders are used to produce and maintain a uniform pressure for the gas torches. The gas is reduced pressure and conveyed to the torches by the hose of the regulator. Regulators include high pressure, low pressure gauges to indicate the contents of the cylinder, the working pressure on each hose. When the gas reaches the torch, they usually are mixed in combustion when it takes place in the welding tip fitted with the torch. Alright, you have your oxyacetylene regulators at the top of each tank. You have an oxyacetylene cylinder, an oxygen cylinder, an oxyacetylene hose. And your code from your regular oxygen cylinder to control oxyacetylene control valve and torches. Alright, and you have your torch, oxyacetylene control valve, and your oxygen control valve. Oxyacetylene welding outfit. The basic equipment used to carry out the gas welding: an oxy gas cylinder in green, an oxy gas cylinder is oxyacetylene gas cylinder is either marine or red. Oxygen pressure regulator, or oxyacetylene pressure regulator, and an oxy gas hose. Oxygen gas hose is blue. Oxyacetylene gas hose is red. Welding torch and blowpipe at the set and the nozzle gas lighter, the trolleys of the transportation of oxygen and acetylene cylinders, set of the keys and the spanners, filler rods and fluxes, protective clothing of the welder, asbestos apron, gloves and goggles, etc. Oxygen gas cylinders. Oxygen gas cylinders are drawn from the piece of high strength of steel with the plate and is available for the common size of 244 cubic feet for industrial plants and 122 cubic feet for and 880 cubic feet. Where the oxygen is stored with the cylinder and the pressure at 2200 psi with filled at 70 degrees Fahrenheit. It's capable of retaining a pressure almost twice the fill pressure. Cylinder valve, the safety nut, the outlet, the hand wheel, and the cap to the cylinder. The oxygen valve of the cylinder is directly proportional to its purpose. In other words, the original pressure of the full oxygen cylinder drops to 10% during the welding. It means that 1/10 of the cylinder contents have been consumed. Oxygen cylinders are usually painted green and are screwed right-handed. Alright, oxygen cylinder valve. The oxygen cylinder valve is more largely brass with the right-handed threads. Its outlet with a threaded machine to comply with the standards set by the Compressed Gas Association, American National Standard Institute, ANSI. All oxygen regulators sold by the U.S. and Canada for use of industrial oxygen cylinders carry with a mating inlet nut and a nipple. The connection is designed by the CGA, or Compressed Gas Association 540. But the oxygen cylinder valve is equipped with a bursting disc, which will rupture, release, or contents of the cylinder if the cylinder pressure should approach a cylinder test pressure, as it might in case of a fire. In order to protect the cylinder valve from getting damaged, a removable steel cap is screwed on the cylinder at all times. When the cylinder is not in use, the cylinder valve is kept on the cylinder and is not used even when the cylinder is empty. Caution: the valve shall never be left exposed. It must always have the regulator attached on or the cap on. If the valve must be open all the way when in use. Acetylene gas cylinders. Acetylene cylinders is used in a solid drawn steel cylinder of common size of 300 or 220 to 75 cubic feet. Cylinder pressure is 250 psi when filled. The acetylene cylinder is painted maroon. The valves are screwed in left hand. The grooved hex head or nut or shank. This shows the cap and the valve and the fuse plugs. Acetylene extremely unstable if it is pure form of pressure above 15 psi. The unstable places special requirements for storage. Acetylene cylinders are packed in purest materials: balsa wood, charcoal, corn pith, Portland cement. This saturated acetone to allow the safe storage of acetylene. The porous filler materials and prevention of the high pressure gas pockets forming the cylinder. Acetylene colorless flammable liquid added with the cylinder until about 40% of the purest metal is saturated. Acetylene and liquid chemical. This dissolves large portion of acetylene under pressure without charging the nature of the gas, and is liquid capable of absorbing 25 times its own vacuum. With acetylene gas is normal pressure. Being liquid, acetone can be drawn from the acetylene cylinder when it is not upright. There are two very important things to remember about dissolved acetane cylinders. First, the acetane cylinder should always be stored in the upright position to prevent acetone from escaping and causing the acetane to become unstable. Second, the Compressed Gas Association G1 calls the withdrawal rate to not exceed 1/10 of the capacity of the cylinder per hour during the intermittent use. The full withdrawal of the contents of the cylinder of the continuous base flow rate should not be more than 1/15 of the capacity of the cylinder per hour. If the acetane is withdrawn too rapidly, quite low of the acetone may come within in vapor or droplet form. The cylinder may cool down so much that it cannot sustain the high rate. This will affect your torch flame, and will mean that the supplier must replenish the acetone in the cylinder more frequently. Many acetone cylinders valves are not equipped with hand wheels and must be operated by a wrench. The wrench should always be left in place while the cylinder valve is open, and acetane cylinders should be open to 1/3 to 1/4 of a turn when using. Alright, your pressure regulator. In an oxygen cylinder, there is a precise relationship between cylinder pressure and cylinder contents. A standard oxygen cylinder that contains 244 cubic feet at 2200 psi at 700 degrees Fahrenheit will contain 122 cubic feet with the pressure is dropped at 1100 psi at 700 degrees Fahrenheit. In the contrast, the acetane cylinder will not precisely half full with the pressure dropped as the half. Note that the change of temperature effect with the pressure of the acetane cylinder as much as faster than rate than affects the pressure of the oxygen cylinder. The pressure in an oxygen cylinder will go up and down only about 4% to 20-degree change in the temperature of 70 degrees Fahrenheit. Full acetane cylinder which has a pressure of 250 psi at 700 degrees Fahrenheit. Will have a pressure of 315 at 900 degrees Fahrenheit, a pressure of 190 psi at 500 degrees Fahrenheit. You may always you must also take the temperature into account with estimating how much the acetane cylinder contains. Alright, your safety device and acetane cylinder. An acetane cylinder is protected with a number of fuse plugs which melt at 220 degrees Fahrenheit or 100 degrees Celsius. These plugs melt and release the pressure in the case of the cylinder exposed to the excessive heat. Some all cylinders that are 10 cubic feet by 40 cubic feet in size have one fusible metal channel located in the cylinder valve. The large cylinders normally used in welding and cutting in the capacity ranging up to nearly 300 cubic feet. With the acetane, have 2 or 4 plugs located on the top and the bottom of the cylinder, and the cylinder is exposed into a fire. One or more safety devices will melt and allow the acetane and acetone to escape, burn gradually, and if it did not have a safety device, the fuel acetane cylinder exposed to the fire would rupture and release its contents at once and perhaps explosively. The acetane cylinders are equipped with fusible metal safety plugs and not rupture discs and safety devices in an oxygen nitrogen gas cylinder. Do not adjust, alter, or change, build, or any extreme work on cylinders, regulator, torches, or any other gas equipment. Do not lift cylinders by the caps or valves. Do not transportate the cylinder without a cap in place. Cylinders must be stored upright position. Keep the valves closed on empty cylinders. Make sure that the cylinders are regularly tested using hydrostatic, non-destructive equipment while in the service. Cylinder testing, cylinder transportation. Never transport cylinders without safety caps placed. When the fuel oxygen should be fastened securely upright at the post or portable cart. The oxygen tank is extremely dangerous for the reason where the oxygen is at a pressure of 3,000 psi. When full, if the tank falls over, a valve strikes something and knocked it off, the tank would effectively become extremely deadly flying missile propelled with compressed oxygen. Never transport the regulators in place. Never allow bottles to stand freely. Allow the chains of them to secure the cart, and some other object cannot be toppled easily. Alright, your manifold system gas welding. With a great deal of oxygen, welding and cutting is done with the using of the gas supplied by the single pair of cylinders. The main situation with the considerable gas welding is done, and in several places where the rate of the consumption is higher, and it must be advantageous to the manifold to use a manifold system. A manifold system, instead of having gas cylinders at each place of the work, they are assembled in one centralized position in special design track connected by a manifold. The gas is distributed by means of pipeline to different workplaces. The manifold distributes welding welding gas and to reduces pressure. There are separate manifolds for oxygen and acetylene gas supplies. The oxygen manifold simply differs from the acetylene manifold in the following which ways. There's no anti-flashback device in an oxygen manifold. 2. Oxygen supplies the copper pipe with the acetylene supply line is a steel pipe. The oxygen pressure regulator is used in the oxygen manifold system. Advantage in using manifolds. Since some gas cylinders have not been scattered throughout the work area, rather they have been kept at a central place. The possibility of accidents is reduced. More space is available to each of the workplace in case one of each of the easily reach the cylinder. Cylinders are transported less distance. There are no replacement cylinders inside the workshop. Oxygen and acetylene pressure regulators. The pressure gas obtained with the cylinder is considered higher than gas pressure operated with the welding torch. The purpose of using the gas pressure regulator is to reduce the high pressure of the gas cylinder to suitable working pressure and to produce a steady flow of the gas under the verifying cylinder pressure. Pressure regulators connect with the cylinder generator and the hose leading with the welding torch. Desired pressure at the welding torch may be somewhere between 35 psi a gallon oxygen or 15 psi a gallon acetylene. Cylinder pressure maximum on the gauge and working pressure and maximum on the gauge. Oxygen has a cylinder pressure of 2200 psi, max on the gauge is 4000 psi, working pressure from 1 to 35 psi, maximum on the gauge 150 psi. Acetylene 250 psi in the cylinder pressure, maximum gauge pressure 400 psi, working pressure 1 to 12 psi, and 30 psi max on the gauge. Pressure regulator is fitted in 2 pressure gauges, one incident with the gas pressure of the cylinder, the other reduces the pressure in which the gas is going out. A gas pressure regulator may be classified as a single-stage regulator or two-stage regulator. A single-stage regulator reduction of the pressure of the cylinder pressure to welding takes place in the single stage. The single-stage regulator is actually needed for both oxygen regulation, acetylene regulation, acetylene welding. However, a single-stage regulator tends to freeze in the cold weather. This is because of the sudden expansion resulting dropping initial pressure causes the rapid cooling of the gas involved in moisture present in the gas, thus the result of the information from formation of ice near the regulation nozzle, which causes irregular seating of the seat of the nozzle and therefore substantially pressure fluctuations. Principle of pressure reduction, two-stage regulator is exactly the same in a stage regulator, but here the pressure reduces the two-stage instead of one, or using 2 diaphragms and 2 control valves, so that the pressure reduction ratio is less abrupt. Good regulators are essential to ensure the even flow of the gas with the blowpipe. The acetylene regulators are constructed more sensitive to the oxygen regulators to take care of low-pressure gases. The acetylene regulators can be interchanged with the oxygen regulators, for which they will not stand the pressure demanded in the first place. In the second, the small quantity of the acetylene gas left in the regulator, the oxygen introduced with the inflammable mixture would be formed with a not advisable account of explosiveness. In many instances, oxygen regulators are put out of the copper diagrams whereas another metal may be used as the acetylene regulator because the acetylene gas attacks copper, usually German silver and rubber diaphragms if used on the account of low pressure used with the charging of the cylinders. Low pressure gauges are used as acetylene regulators. The difference between oxygen and acetylene pressure regulators. Acetylene regulator, the cylinder and hose connections have been left-handed threads on the acetylene regulator. Oxygen regulator, the right-handed threads are in this case. The oxygen acetylene regulator. Acetylene connection nuts have been chamfers and grooves cut in them. Oxygen regulators. Nuts are plain with no chamfer or grooves. Acetylene regulator. Color band on the acetylene regulator is maroon or red. Oxygen regulator is either blue or black on the oxygen regulator. Acetylene regulator. The inlet of the high pressure gauge of the regulator reads up to 8 bar. The inlet of the high pressure gauge on the regulator reads up to 100 bar. Oxygen regulator. Acetylene regulator. The outlet and low pressure gauge of the regulator reads up to 1 bar, and the oxygen regulator, the outlet low pressure gauge reads up to 4.8 bars. Caution: never use oxygen and fuel gas for cylinder except through the approved pressure reducing regulator. Never attempt to use a regulator except with the gas surfaces for which it was designed. Generally speaking, the inlet connection is installed with the regulator manufacturer mismatching impossible. However, they cannot always be in case of since there was just enough mechanically distinct connections to permit each of the gas individual treatment. Therefore, some of the gas, for example, inert gas and certain fuel gas, is treated with the group of the propane regulator within the fit of the acetylene cylinders, but should not be used. Oil and other petroleum products must never be used with oxygen regulators because the products will in either case cause a regulator explosion of the fire. Alright, your gases and hose clamps. The hose clamp is to make the connections between the torch and regulators must be strong, non-porous, light, with the flexible enough to make the torch movement easy. The most common type of the cutting of the welding in this twin double housing consisting of the fuel house oxygen joint together inside to side. Size determined with the inside diameter of the proper side that is used depends on the type of the work in which it is intended. Hoses used in light work has either 33 to 3/16 or 1/4 inch inside diameter, 1 or 2 piles of fabric. The heavy-duty welding cutting operations use the hose with the inside diameter of 5/16 and 3 to 5 plies of fabric. Single hosing available for the standard size at 1/2, 3/4 inch, and 1 inch size is the large size of the heavy-duty heating for using the large cutting machines. Rubber flexible hose. Oxygen hoses are green in color and have red right hand thread. Acetylene hoses are red in color and are left and hand threaded. The nut of the acetylene connection has a notch and runs around the central distinguishing from the nut and the oxygen connection. This is all a safety precaution to prevent hoses from being hooked up the wrong way. Alright, some precautions are being taken when using the reinforced rubber hoses. Only one gas should be used in a hose. For example, using an oxygen hose carrying a acetylene could cause a serious incident. Hosing should never be patched or repaired. Hot metal should never be placed on the hose. The length of a hose used is important, but the delivery pressure of the torch verifies the length of the hose. 20 feet to 3/16 of an inch hose may be adequate job, but if the same hose was 50 feet long, the pressure drop would result in insufficient gas flow to the torch. Longer hoses require larger inside diameters to ensure the correct flow of the gas to the torch. When you're having the problem welding or cutting this area to check. Hose clamps. A metal clamp is used to attach a welding hose to the nipple, but there are basically two types of connections that can be made. The first is using a Jubilee clip. The second option is a crimp connector. The second option harder. The second option is probably safer and harder for this type of the connection to come loose. The hoses should also be clipped together in intervals approximately 3 feet apart. Alright, this shows the Jubilee clip and the crimped connector. Alright, your check valve. A check valve is glass with one direction position with the torch inlet with the regular outlet. The purpose of the check valve is to prevent the flame of the oxygen mixture being pushed into the cylinder, causing backfire, flashback, and explosion. A backfire is caused by flaming going out suddenly on the torch, and a backfire may occur when a tip touched against the workpiece. The flame setting is too low. The tip is dirty and damaged or loose. The tip is overheated. When the torch backfires, it causes a flashback. A flashback is a condition in which the flame burns inside the tip of the torch or on the hose. The flashback can cause by the improper mixture of the gas, which increases the rate of the flame propagation to such extent that the flame of the flashback mixture chamber. If it is not snapped, the flame will ignite the mixture and will travel backwards from the torch along the hoses and through the regulator into the cylinder. To prevent such an occurrence, the flame arrestor should be installed. The flashback arrestor, not to be confused with a check valve, prevents the shock wave of the downstream coming back up in the hose entering the cylinder, possibly rupturing it. If there are quantities of fuel oxygen mixture inside part of the equipment, specifically the mixture and the blowpipe nozzle, that may explode, and if the equipment is incorrect, should be down and the acetylene decompose in excessive pressure of the temperature, the flashback arrestor will remain switched off until someone resets it. Alright, refer to Section 4, Safety Working Practices, and illustrating case study of safety incidences in the UK. Combination check valve, flashback valves can be placed in torch or regulator. Alright, the welding torch and blowpipe. Welding torch mix oxygen and silicone with the desired proportions because of the mixture at the end of the tip provides the means of moving the direction of the flame. There are two types of welding torches, namely high pressure equal pressure type or low pressure injector type. The high pressure blow pipes and torches are used to dissolve the silicone stored in the cylinder at a pressure of 117 psi. Low pressure blow pipes are designed for the silicone obtained with the silicone generator at a pressure of 8 inches head of water, approximately 0.3 psi. In the high-pressure blowtorch, the most oxygen and silicone are fed with the equal pressure of the gas and mixed with the mixture chamber prior to being fed to the nozzle tip. The high-pressure torch also causes the equal pressure of the torch is most commonly used because it's lighter and simpler. It does not need an injector. The operation less trouble so that it does not suffer the backfires. It does not suffer from backfires to the same extent. Alright, this shows you the welding tip of the torch or welding tip of the mixing chamber, your silicone oxygen control, your oxygen silicone connection. Change the power of the welding torch does not necessarily change the nozzle tip in size, increase or decrease in the gas pressure appropriately. The real tip of the oxygen and silicone welding pressure is the flame, not the torch. When you cut the oxygen cutting, what must be considered poor oxygen, just a second tool working in hand of the hand flame to produce the open flame. When using a welding torch fitted with the appropriate sized welding tip or head or tip, to produce both flames and oxygen jet, they use in cutting of the torch cutting attachment equipped with the appropriate cutting nozzle or tip. Welding nozzles and tips. Welding nozzle and tip is the portion of the torch which is located at the end of the torch containing the opening of where the oxygen and silicone gas mixture passes prior to the ignition combustion. Depending on the use of the design of the welding torch, interchangeable nozzles may consist of either a set of two tips with the screws on which the head of the blowpipe, a set of gooseneck extensions fitting directly into the mixture of the portion of the blowpipe. A welding nozzle enables the welder to guide the flame directly in the maximum ease and efficiency. Following the factors are important selection of appropriate welding nozzle. The position of the weld, the type of the joint thickness for the size of the welding required for the job, metal alloy to be welded. To provide different amounts of the heat to the metal, the different thickness of the welding tips are made with the various size. The size of the welding tip is determined on the diameter opening of the orifice of the tip. As the orifice increases, the greater amount of the welding gases pass through and are burnt with a surely greater amount of heat. Choice of the proper type of the size is important for the good welding. For the welding thicker material, larger size tip is used with some apply more combustible gas, more heat with the shorter giving size of the tip of the welding, various thickness metal along with the oxygen and silicone pressure used generally to provide with the manufacturer. Care of welding tips. All welding tips are made of copper and may be damaged careless handling. Nozzles should never be dropped and used in moving and holding the work. Nozzle seats and threads should be absolutely free from foreign material in order to prevent scoring of the tightening and assembling. Nozzle orifices should only be cleaned with the tip cleaners and should be designed for the purpose. Filler metals. Alright, your filler metals are usually supply additional material to the pool, assisting the filling of the gap of the groove that forms an integral part of the weld. Filler rods have same or nearly the same chemical composition of the basic metal and are available to variety of the composition. For welding different materials and sizes, the consumable filler rods may be bare. They may be coated with flux. The purpose of flux is to retard the oxidation of the surface of the part of the weld by generating gaseous shield around the welded zone. The flux also helps to solve and remove oxides and other substances. From work pieces such as contribute to the formation of the stronger joint, the slag develops and protects the molten metal puddles for the metal against the oxidation and cools. Characteristic of good flux. The melting point of the flux must be lower than either metal oxide so that they will be liquid. The ideal flux has exactly the right fluidity when the welding temperature has been reached. The flux will protect the molten metal from the atmospheric oxidation. Such fluxes will remain close to the weld and are instead of flowing all over the base metal and some of the distances of the weld. Your composition of flux. Flux are different composition according to metals which were there to be used. In cast iron weld, the slag form the surface of the puddle. The flux serves to break this up. Each part with the carbonated soda, bicarbonate soda make a good compound for this purpose. Non-ferrous metals used in requiring flux. Copper requires filler rods containing enough phosphorus to produce metal and free from the oxides. Borax, which has been melted and poured in, often used in the flux of the copper alloys. A good flux is required with aluminum because of the tendency of the heavy slag formed with the mix of melted aluminum weaken the weld. For aluminum welding, it is customary to dissolve flux water applied to the rod. After welding aluminum, all traces and fluxes shall be removed. Gas lighter. A gas spark lighter provides a convenient, safe, and inexpensive means for lighting the torch. The match sticks should never be used for this purpose because it is put off the flame produced by the ignition, and cellophane flaming from the tips is likely to burn the welder's hand, and spark lighters are constructed with a flint and steel. A gas cylinder trolley. Trolley should be capable of accommodating one cylinder gas and one acetylene cylinder is required with the gas cylinder. Normally, cylinders can normally be mounted on the torch side with the side. When working with gun and planning access to narrow gangways has an advantage. Trolleys may be rubber tires, steel rim wheels. The gas cylinder are held in place in the chains and supported on the bottom of the steel platform. Goggles. They are used to protect their eyes from operating with a harmful heat. The radiation, infrared, ultraviolet produce during the weld. An apron and goggles and safety goggles. The molten metal depends on the pop and splatter as the heat is applied. But the oxygen reacts with the superheated metal. It is critical that the operator use the oxyacetylene welding cutting process as well. Proper gloves using appropriate safety goggles and face shield. The goggles and face shield protect the eyes from sparks from flaming hot metals particles. The goggles and face shield use a special lens to protect the eyes from light damage. The variety of lenses used depending on the type of the welding cutting that needs to be done, the type of the material, the thickness of the material, and if a protective eye shield is not used, painful burns can occur on the surface of the eye and could result in permanent damage. 2. Oxyacetylene welding.